Hi, everyone. I'm really excited to be giving this talk for a few reasons, but the main reason is that this is actually going to be quite a different kind of talk than your standard QBist fare, because it's going to be explicitly about ontology. And the thing with QBism is that because it's a methodology towards finding an ontology, it tends to be by nature very conservative. What I mean is that most of the QBist literature to date has busied itself with the project of sorting out how much of the quantum formalism is subjective. And the idea being that whatever is left over at the end will be maybe possibly candidates for an ontology. But until recently, QBists haven't really explicitly focused on those little bits that are left over and tried to articulate what that ontology might be. I say until recently because over the last months in our group discussions, kind of behind the scenes, we've been having lots of discussions about what a QBist ontology might look like. And we've been talking to philosophers, particularly phenomenologists lately. I'm a big fan of phenomenology, and you'll notice that in my talk. But we've been throwing ideas around, and this is still completely the wilderness to us. So I just want to make a kind of disclaimer that what I'm about to say is just think of me as somebody who's kind of soaked in the QBist mentality. So I've been there, in the group for a while. I started in 2019, and even before that, I was starting to think like a QBist just through my own path of research. So I really, I drank the Kool-Aid, I've absorbed it all. But for me, I'm determined to get to an ontology. And so you can think of this talk as kind of saying, okay, what if we just turn our focus in the other direction and say, let's take those small ingredients that might possibly be the ingredients for an ontology and just dive right in and see what happens, see if we can build something, and most importantly, see where it might break. So this is very much, I'm going out on a limb here. Don't take any of this as QBist canon. This is wild speculation, but I hope it might give you some idea what a QBist ontology might look like. All right, with that disclaimer out of the way. So yeah, I mean, QBism in a way is very enticing, to me at least, because if you have just the passing awareness of QBism, you would know it as the interpretation that says the quantum state is subjective, which is true, but it's a bit misleading because who cares about the quantum state? There's this tradition of thinking that finding an ontology for quantum mechanics boils down to finding out how much of the quantum state represents subjective or epistemic knowledge versus how much represents objective or ontological fact. But this completely ignores the possibility that your interpretation might not look in the quantum state for the ontology at all. It might not belong to one of these ontological model frameworks where, the state is a partial state of knowledge of reality. So we want to go beyond that. And it's worth remembering that Jaynes didn't talk about the quantum state. This is just a rehashing of a quote that Chris showed. Jaynes said, our present quantum mechanical formalism is not purely epistemological, blah, blah, blah. If we cannot separate the subjective and objective aspects of the formalism, we cannot know what we're talking about. Jaynes is referring to the quantum formalism as a whole. And already Chris pointed to one of the candidates for something in the formalism that might maybe have something to do with the ontology is the Born rule. And that's really kind of a holistic feature of the quantum formalism because it involves a combination of states and operators and so on. It represents a kind of relational structure. Of course, there are a lot of things that QBism has said are subjective besides states. I mean, POVMs unitaries, Hamiltonians, based on the cubist research to date, these are all subjective. So there is a natural question, where should we look in this seemingly, this interpretation that's seemingly an ocean of subjectivity? Where's like a life raft, like a handle to grab onto to get to an ontology? And in this talk, I'm going to focus on just one possible handle, which I think is really the first place we need to get a grip, which is on what I'm going to call measurement events. I'm not really going to talk about the Born rule in this talk, but that's mostly because I haven't had that much time to think about it, and it's still further beyond where we're able, what we're minimally able to say about an ontology. Same thing with locality. I'm not going to talk about that. That's mostly because of lack of time. Maybe we can discuss that later. But before I dive into talking about, what could be ontological about these measurement events in cubism, I have to kind of prepare your minds a bit, because the thing with cubism is that it exists in a kind of philosophical setting, which is a way of thinking about physics and the world and epistemology and ontology, which is completely different to what is implicitly assumed in most physics textbooks. And most physicists just aren't used to thinking about the world in this way. There's a reason. I used to think it was strange. Why does this Chris Fuchs guy keep quoting William James in all of his papers? It seems irrelevant, like, get to the physics, man. But it was when I started to read William James that I understood how important it is to really shift your whole mental framework before you can really start to appreciate what cubism is trying to say. So before anything, let me try to give you a flavor of that. And I'm sorry if this makes your head spin a bit. It's pretty wild. Get ready. So I'm going to organize this around two oppositions, which are very important to all of these discussions. There's the subjective versus objective opposition, obviously very important to cubism, and the epistemic versus ontological. These are kind of obviously related to each other. They tend to be conflated. But I want to try to orient you as to how a cubist sees these oppositions. And the key point is that for cubists, these are not dichotomies, they're dualisms. This is one of the things that philosophers have helped me to appreciate, is the subtle differences in the choices of words that you use. So what's a dichotomy? A dichotomy is when you have a divided nature. You have two aspects which cannot coexist because they mutually exclude one another. Whereas a duality is a double nature. It's things which can in some way coexist conceptually in a mutually dependent or complementary way. And cubism's orientation is that both of these oppositions are, they're not dichotomies, they're dualisms. So let me walk you through what that means. Firstly, let's take subjective versus objective. So you might, before I blast you with that page of text, you might have this kind of naive idea, like, we know what's objective and subjective. Things are either one or the other. My liking of cheeseburgers is subjective, and Bell experiments on the Canary Islands are objective. Stuff that science gives us is objective facts, and the rest is all subjective. Obviously, that's kind of naive. And if you really want to delve into the subtleties of this, I highly recommend reading this book, Objectivity, by Lorraine Daston and Peter Gallison, which is kind of an in-depth study of the history of objectivity in science. And they really show how, first of all, objectivity is a relatively new thing in science. It was only in the latter half of the 19th century that it became a kind of goal, an explicit goal for scientists to be objective. Before that, it was even kind of the opposite. Like, to be a scientist, you had to be someone who was really sensitized to nature, so that you could see, truth to nature was the concept, which wasn't at all objective. There were only certain special subjects who had that level of sensitivity to be scientists. Anyway, it's a fascinating topic, but for my purposes here, the point is that objectivity is defined as the suppression or elimination of certain aspects, which we then define as the subjective aspects. So objectivity is always defined relative to a notion of subjectivity. The two are interdependent concepts, and historically the meaning of them has shifted along with what we understand to be the ideal scientist. So the idea of what scientific objectivity is closely intertwined with the idea of who the scientist is as a subject. And that's what I mean by saying that this is a dualism and not a dichotomy. So to make that more explicit, consider these two possible definitions of objectivity, loose definitions. Number one, that which exists outside and independently of any subject, i.e. objectivity excludes subjectivity, or that which is indifferent to any particular subject, i.e. objectivity is that which is invariant among subjects. Option one is a subjective-objective dichotomy, because what's objective is totally existent, separate from subjects. It's out there, has nothing to do with us. Number two is what cubism endorses, something like number two. It's an invariance among a set of subjects. In order to understand what's objective, you need to know something about how the subjects vary or don't vary among themselves. All right, switching to the next dualism, the epistemological ontological opposition. That's also a dualism in cubism. Why? What could that mean? So this one's probably, I would say this is the most difficult aspect of the cubist mind frame to wrap your head around. And I'm still haven't quite got there yet. But reading the philosophers, like I'm a big fan of Merleau-Ponty and the phenomenologists in general, Husserl, they give some idea of what this might mean. So to give you just the general idea, I'm going to contrast two opposing views, what I'm going to call the Cartesian view versus the pragmatist or phenomenological view. And I apologize to the philosophers for bulldozing over all the subtleties here. Okay, here's my little bad drawing of the Cartesian picture. You have a mind-world dichotomy. Things that exist either exist in the mind or they exist out there in the world. They either have a physical nature, or sometimes they use the word transcendent. They're out there, they transcend the mind in that sense, or they're immanent, they're in the mind. And it's either one or the other. And the way that these two things interact, the way that we, in our sort of subjective world of thoughts and feelings and so on, the way that we get knowledge about the world is through perception, which in this picture is seen as a kind of a process whereby something out there in the world, like this tree, impacts somehow upon our senses, and that causes us to have a mental representation of the tree, the image of the tree as it were, as we experience it. And we just hope to God that these two things correspond, and you can go down that rabbit hole of how can we be sure that what our senses represent to us corresponds to what's out there in the world. But the point is that there's a clear dichotomy between these two. And in fact, you might get the sense that this barrier between the two sides is a bit problematic philosophically. And indeed, many philosophers have decided that it's actually much more consistent to just throw your lot in one side or the other. To say all of existence belongs, let's say, to the immanent, to the mind, or all of it is physical. So that gives us two kind of Cartesian extremists. There's the idealists. Those ones think reality is ultimately, anything that exists is of an ultimately mental character. We can't ever hope to claim to have knowledge of something outside of the mind. And then there's the empiricists or physicalists, as I like to call them, who say reality is ultimately only of a physical character. Like, sure, you can talk about mental stuff, but that's all emergent or illusory. At the fundamental level, it's all atoms and the void. And I'd say probably most physicists subscribe to this. I do think that this might be an underappreciated difference between Cubism and Ravelli's relational interpretation, because I have the impression that the latter would endorse physicalism, the idea that ultimately it's all atoms and the void, whereas Cubism rejects both of these extremes, because Cubism rejects this whole Cartesian picture altogether. So what could you have instead of that? Well, I think Cubism would prefer something like this. You have a mind-world dualism. So what is real has both what we would call mental and physical aspects. You know, if you're looking at a chair and you're feeling hungry, that initial experience is a holistic thing a priori. You don't separate the hunger from the chair, but actually we know that you do, because when you walk around, the chair disappears and the hamburger appears, and then the hunger goes away. And then you come back to the chair and it's still there, but without the hunger. So you start to differentiate things that you attach to yourself and things that you attach to the world. This is a caricature, of course, but the idea is that we begin with a reality that's a kind of inextricable mishmash of the mental and the physical, and it's through the subsequent evolution of this reality that we begin to distinguish one aspect from the other. But that means the distinction has a character of a dualism. It's never a perfect divide, and it's always unfolding and being renegotiated. So I'll make a couple of notes about that. One of the obvious things, you know, when you hear something that phenomenologists like to say is, you know, I mentioned that perception in the Cartesian picture. Here we go. Perception is that you represent what is out there in the world, because there's two copies of the tree, right? There's the one in the world and there's the tree in your mind. But in phenomenology, perception presents it just as it is. And something you might object to that is, well, what happens when you're mistaken? I mean, when you're hallucinating or having a dream or, you know, seeing a magic trick. Things often turn out to be different to how they first appear. And in the Cartesian picture, that's just because, well, your senses can't be trusted to always give you an accurate picture of how things are. But in the phenomenology pragmatist picture, that difference between the appearance and the reality is actually a difference between two realities, or rather it's a changeable reality. First, it appears as one thing and then it appears as another. A second note, in the phenomenology pragmatism picture, the mind-world boundary is not fixed, but as I said, it's evolving organically and continually in flux. So reality never quite fits cleanly onto one side or the other of the mind-world divide. And so when we talk about the agent and the external world in Cubism, that boundary between the two becomes a dynamical object. Ultimately, when we talk about an ontology, we're going to want to talk about how that boundary can move with the ebb and flow of reality, as it were. And number three, consequently of all of this, what we're calling ontologically real, you know, let's say you're experiencing a chair or a tree, it can be personal in the sense that, you know, you might be hungry when you're seeing it, so that becomes associated with that piece of reality, or you're seeing it from a particular angle corresponding to where you're standing. So it has this personal element, which means that what we're calling reality is not necessarily objective, because it can vary from subject to subject. Different people can have different experiences of the same tree. So in Cubism, it's important to distinguish between when we talk about reality and when we talk about objectivity. It's true that anything objective has to ultimately be founded in reality. But conversely, you can have elements of reality which are not strictly objective. Okay? I'm sorry, I know it's a lot. But don't worry, I'll try to boil this into something concrete. That's the whole point of this talk. I just want to say one last thing about the boundary between the agent and the external world, because this thing about the boundary moving and moving with reality is kind of fascinating to me. And there's this really nice example that appears, I think Bohr uses this somewhere and Merleau-Ponty uses it. I don't know who used it first. But consider a blind man walking with a cane. And at first he's holding the cane loosely in his hand. So in this case, I would argue the natural place to draw the boundary between the agent and the world ends at his hand. He feels the stick in his hand as if it's a foreign object. When it strikes a rock, he feels the vibrations of the stick in his hand and he infers that there is a rock there. But what is real in this example would be the vibrations in the hand. That's, let's say, the measurement event. I'll make that more precise later. And the inference is that there is a rock. But if he's holding the cane tightly, the experience is different and the measurement is different. Reality is different. With a tightly held cane, he feels the rock immediately and without reflection. It's just boom, there's a rock. It's as if the cane is an extension of his own arm. So what we have here is a possible shifting of the boundary between the agent and the world, and therefore a shifting of what the element of reality is that's occurring in this measurement. This is kind of prefiguring some things that I'm going to talk about more. So don't worry if it's a bit confusing. It'll still be confusing at the end, but you'll have more details about it. Okay, I want to close with this summary so that the point here is that this epistemological ontological divide is a dualism precisely because this boundary between what's an ontological fact and what's an epistemological inference is movable and shifting in the cubist picture. It depends on details of the situation, on the physical connection between the hand and the cane. Is it a tight grip or a weak grip? It would be nice to delve into the details of how that works. But so now I'm going to get into concrete details. That was the, put yourself in a cubist mind frame. And now you're probably totally lost in saying, okay, how can we even begin to formulate something that a physicist would look at and say, yeah, that's an ontology. That's a story about reality. And I'm just going to plunge in and make a guess and see where it goes, okay, in the spirit of cubism. So this is the challenge facing a cubist ontology. And the rest of this talk is like, where might we run into trouble with this? There are at least two definite ontological claims that I think it's safe to take as our starting point. I don't think other cubists would disagree that these would be okay. Axiom number one is that reality comes into existence in measurement events, which are ontological primitives. Nothing terribly new there. We always knew cubism took measurement as a primitive concept. And now we're just saying that, more than just saying that the measurement outcomes are experiences of the agent, we're saying that those experiences of the agent are experiences of reality. There's an element of reality corresponding to them. Just pushing it a little further. And axiom number two is that the measurement event is real only, question mark, to the agent who performs the measurement. I say only question mark because there's some doubt about whether cubists will endorse the only or not. I'll talk about that in the last half. So I'll go through these axioms one by one and stretch them to their limits and see where they break. So here's axiom one in some more detail. Firstly, what do I mean by primitive concept? What I mean is just that when you have a measurement event, you're not going to try to explain what it is in terms of any more fundamental concepts. In a slogan, stuff happens. Measurement events happen, an agent takes an action, gets a result, and we can study the structure of those, but we're not going to question why they happen. We take it as an axiom that they do happen. Now, what is the structure of these things? They do have a structure in cubism. We know that every measurement event has two components. There's the action that the agent takes upon the world, and like the choice of measurement they're going to perform. And then there's the result, the world's reaction on the agent. This is kind of like a generalized Newton's third law, if you want. And I want to emphasize that the action and the corresponding result happen together in the same moment. So it's not quite the same as when you think of settings and outcomes in an experiment. A setting is like you set the dial to some number, and then the outcome is some time later you see something go click. In this case, you actually have two measurement events. The setting is you take the action of turning the dial, and the immediate result is that the dial turns and ends up at some value, right? And then there's a second measurement event, which we normally just call the outcome, but it's actually a pair of an action and a result, which is you're listening for a click, that's the action, and then you hear the click. So I just want to flag that when I say action and result, I'm using those words because I don't want you to confuse them with measurement setting and measurement outcome, as usually used in the literature. And finally, measurement events have a feature that I'm going to call genuine novelty. And what I mean specifically by that term in the context of this talk is that when a measurement happens, it neither reveals a pre-existing element of reality nor produces an element of reality that persists in its absence. Both of those are important in cubism. And this goes together with cubism's rejection of hidden variables. There are no elements of reality except for those that appear in measurement, measurement results to the agents doing the measurements. In between, we're not going to say that there's hidden variables that fly around, carrying the memory of what those results were. And probably, if you've been following all of this, you've already thought of several problems that might arise with these axioms. So here's some challenges, okay? I'm trying to anticipate what you might find problematic, but feel free to add to this list later on. So firstly, what are the kind of primitive terms that we should use in describing measurement events? Or in other words, what defines the boundary between what is measured and what is merely inferred? So if you take, let's say, using a Stern-Gerlach apparatus to measure an electron spin, should we say A, B, or C? A, I measured the electron spin in the Z direction and the outcome was spin up. That's kind of what we typically do say in our physics papers. Something you might see in the grad student's lab notebook would be, I aimed an electron beam through the magnets and I saw the electron arrive on the upper half of the glass plate. Notice the different terms entering into this story. They're more visceral, but they still are loaded with scientific meaning. And finally, you might have C. I aimed a weird looking cylindrical thingy between two funny shaped blocks of metal and I saw a black dot appear above a line on a piece of glass. Well, that would be someone who, like a journalist, who happened to walk into the lab and has no idea what these things are. So there's a real question, like, well, measurement events are supposed to be primitives in the theory. So it really matters, what are the canonical terminology that we're supposed to use to describe these events? And I'm going to go ahead and try to give you a flavor of what my answer would be, without putting words into the mouths of any other cubists. We have to remember that all measuring instruments, whether made of flesh or metal, are to some degree theory-laden. So, for example, take your eyes. You might not be used to thinking of your eyes as being theory-laden, but if you look at an anatomy textbook, you'll find a diagram of the eye and how it works and all of its structures and a theoretical model of it, which you can even use to correct problems with your own eyes. Let's say by designing a pair of spectacles that will correct aberrations in your cornea. And I would argue that that's not fundamentally different to what we do with a microscope either. Just because we're not consciously aware of the theoretical ladenness of our eyes doesn't mean that it isn't there. And we might become very aware of it if one day you should have problems with your eyes. You'll discover how theory-laden they are. But conversely, theories are also measurement-laden. So what I mean by that is, well, how did we come up with our theory of the eye, let's say, our model of the eye? Well, we did that by dissecting a bunch of human and animal eyeballs, you know, viscerally cutting them up with the scalpel and looking at what we saw, you know, with our eyes. So this is kind of a chicken and egg problem. We needed to use our eyes in order to study the eyes, in order to understand how the eyes that we're using work. But how is it that we knew that we could trust our eyes for doing this task if the eyes are the very things that we're investigating? Of course, most of you will appreciate that this is not a vicious circle, or else science wouldn't be possible. The real story is that it's more like a kind of a bootstrapping that we do. Don't worry, I'll get to the point soon, I promise. Bear with me. So in fact, what happens is we begin the story with some implicitly trusted instruments for making observations. You know, just, yeah, take your organs. You trust your eyes implicitly, and you make observations about falling objects, just like Galileo, pendulums and so on. He didn't worry if his eyes were working, he just observed. Okay, but then you know, of course, that your implicitly trusted instruments are only trustworthy up to a point. I mean, you're aware that they're not super accurate. So you make a theory based on your observations, but it's a simple theory. You don't want to overreach, you know, your own limitations of your own senses, but you can make enough observations to get a theory and then use your theory to build a better measuring instrument. You know, in this case, I've got the guy building a little telescope using his theory of matter, which he got using his eyes. Okay, and then you test your theory out, you do some more observations, and finally you build an instrument and calibrate it until you're ready to say, I now implicitly trust that the data this instrument is giving me, you know, is, you know, I can build theories on it. So you extend the apparatuses that you implicitly trust to include the one that you just built. And that allows you to enhance your observations. You can now make observations in new domains and, you know, to new levels of accuracy. Maybe even observe new things that you never saw before, like microscopic germs. And then the cycle begins again, because now you can make more accurate theories, and around we go. And that's nice, because at each step in this process, you'll notice that there has to be a set of implicitly trusted instruments. The ones that you're just so comfortable using that they're second nature, that you believe they work and you're no longer consciously modeling them, just like your eyes, assuming that they're working fine. And so I'm going to say the primitive terms entering into measurement events are precisely the terms that are appropriate to these implicitly trusted instruments. Doesn't matter if it's theory-laden, as long as the usage of the instrument is sufficiently streamlined and reliable, it can be declared a literal extension of the agent's bodily senses. So agents in cubism on this thesis are generally prosthetically enabled beings, cyborgs. I have a paper about that if you want to know the details. You know, you can assign POVMs to these things and do the whole mathematical machinery. But let me skip now to another objection to this point 1C, which I think many people probably would have objected to, which is the idea that the elements of reality only turn up in measurement events, but not in between. So how do we account for the fact that repeated measurements tend to produce the same result? And it's kind of a trick question because actually they don't in practice. You have to tune things carefully and make sure that you're doing it just right in order to get the same result. But we know it's possible to do that. So can cubism account for that fact? And that's an easy one. There's no reason why we can't just postulate that the world has an inherent tendency to repeat itself under certain conditions. i.e., once a result has come into existence for the first time as a consequence of a certain kind of repeatable measurement, then it seems to be the nature of the world to produce the same result again, if the agent is careful to repeat the same actions. I'm going a little rapidly because I want to make sure I finish on time, because now we're getting to the really interesting stuff, which is to do with axiom 2. Axiom 2, remember, says the measurement event is real only ? Relative to the agent who performs it. But we have some options about this. At the most conservative, we could say it exists at least relative to the agent who measured it. But we could say it exists at least relative to those agents who participated in measuring it. Could we say it exists regardless of whether anyone measured it? Well, no, we can't do that, because cubism, remember, part of the structure of a measurement is an action that an agent takes to elicit it. So you can't have measurements without agents, but any of these other two might be okay. Certainly the last one is always going to be acceptable. It exists relative to the agent who measured it. But could there be situations where it exists relative to other agents? And strangely enough, the literature is kind of divided on this. You can find quotes, which I won't walk you through these now, maybe just mention one of them. When I contemplate a measurement, I contemplate its results, outcomes, consequences for me, no one else. It is my experience. That seems pretty clearly to say, nope, can't share that with anyone. It's private. But here's some quotes which suggest that it might be shareable. The greatest and most difficult task will be to disambiguate the pure experience notion from the agents. On participatory realism, Chris Fuchs says that. And here's another Fuchsianism. In the Wigner's friend scenario, when Wigner turns his back to his friend's interaction with the system, that piece of reality is hermetically sealed from him. Kind of hinting, I think, that if Wigner doesn't turn his back, the friend's reality might not be hermetically sealed from him. I think it's suggestive that we're at a crossroads here. We could try to make a cubist EPR reality criterion like this. When an agent A measures a system X at time t and obtains result R, then there is an element of reality corresponding to R at time t relative to, well, we have a choice. Either it's only relative to the agent A, or it's only relative to a set of agents who satisfy certain conditions relative to A. The trouble is, can we make those conditions explicit? So firstly, I want to say, well, why don't we just pick this first one that I've called XS? You'll see why I call it XS, okay? If we just take the conservative view, it's only relative to the agent, that implies the elements of reality corresponding to measurement events are partitioned into disjoint sets, each set corresponding to a distinct agent. They can't be shared. And this leads us to something like what I like to call an island universe ontology. It's not exactly solipsism, because you have multiple agents. They might even know about each other and talk to each other. But the point is that each of their measurement events is completely distinctive from each other's. Their universes are private, fundamentally. And that seems pretty watertight against any no-go theorem of the Wigner's friend type. But it also seems to conflict with the changeable nature of the boundary between agents, I mean, instead of just stopping at having that boundary shift to include a measuring apparatus, couldn't we extend it to include another agent, for example? And on top of that, it just seems excessive to make such a conservative assumption when maybe we don't have to. It might be more interesting to ask if we can stretch and push cubism to allow for agents to share measurement events in the ontology. I called it XS because, you know, it's excessive, I think. So I think that we should go with in excess. So I want to say that under certain conditions, measurement outcomes can be shared between agents, but there are significant challenges to doing this. Not least of which is how to define these conditions precisely so that we avoid all variations of Wigner's friend no-go theorems. But also because in cubism, it's very important that different agents should be allowed to assign different POVMs and measurement results to the same measurement event, because remember, things like POVMs are subjective. They should vary between agents. So what kind of, you know, consistency constraint could we impose that would nevertheless make these things commensurable between agents? And last but not least, this seems to be calling for a way that a measurement event can exist or happen relative to a whole set of agents, a multi-agent, let's say, in such a way that it does not distinguish any particular agent from among the set. But we can't do that by appealing to a view from nowhere. We can't take a God's eye view of this. So the question is, well, can we nevertheless give meaning to a measurement result for a multi-agent, which is still not a measurement result for God, as it were? And it's not at all clear that that would be consistent with the principles of cubism. But I think it's really worth trying, because if cubism could accommodate this postulate, which I call in excess, it might solve Wheeler's worry. I found out from Amanda Gefter, who has studied Wheeler's journals in depth, that this was a question that really gave Wheeler headaches for a very long time. He wrote in his journal, "How are acts of observer participancy fitted together? That's the central mystery. Is there any point partway between all and none on this issue? Each of us a private universe? Preposterous. Each of us see the same universe? Also preposterous." And I think that that might be something that would take cubism in a really interesting ontological direction if it could be answered. So thanks for listening. I think I'm at time, and I'll stop there.
Thanks, Jacques, for a wonderful, wonderful talk. All right. So we have already a couple of questions. Again, I'll direct people to use the hand-raising tool or to ask questions in the chat. We have a couple of questions already in the chat, and I see some hands raised. The first question I have is Mike Ridley.
Hello. Can you hear me?
Mm-hmm.
Hello? Yep. Okay.
Yep.
Okay. So I saw this slide on objective versus subjective, and then epistemic versus ontological. I just wonder if you could go back to that.
Mm-hmm.
So you seem to set it up, set up the discussion by saying that there's been an antagonism between epistemology and ontology traditionally in philosophy, and that this was somehow related to the mind-body distinction. But I don't think that's true. I mean, if you study the Western philosophy, you know, there's a long history of the problem of substance and whether substance is fundamentally mental or physical. You know, this discourse takes place solely on the side of metaphysics / ontology, and you know that's a debate that runs through the work of Descartes, Leibniz, Spinoza, Immanuel Kant, David Hume, but there was never a suggestion that there was an antagonism there. And I think what I'm trying to get at is that there's a very reasonable position, I think, which is actually the position of most philosophers, which is that epistemology deals with what can be known, metaphysics deals with what there is, or maybe what is most fundamental. And the relationship between them has always been understood to be one of not, whether things are categorized into mind or body, but of the direction of explanation. So there's a simple idea that the world is a certain way. Metaphysics talks about that, and because the world is that way, we know stuff about it, and our knowledge is justified in virtue of the way that the world is. And I think this basic understanding was sort of attacked with the development of logical positivism in the early 20th century, where basically any sort of metaphysical discussion about what was behind experience at all was dismissed as God's talk or nonsense. And whereas, I mean, it's just model building. It's just simple model building. So this sort of complementarity between epistemology and ontology, I would argue, is completely standard for anybody who's familiar with most of Western philosophy. It's not a radically new idea, this this trial and error relationship between the two.
I'm happy to hear that, because that means that philosophers are maybe more on Cubism's side than I thought. But this also ties into my comment, my disclaimer there about apologies for bulldozing over all of philosophy here. I knew I was going to rub some feathers the wrong way, but it could be that I'm reacting a bit to maybe a kind of straw man that I've constructed here, just as a way to bring into sharper relief this idea, like where Cubism wants to situate itself, is definitely along those same lines of not seeing such an antagonism there.
Right. I mean, this whole epistemic ontic distinction between, the best way to interpret the quantum state, for example. I would argue that it's similar. You have a map, a representation of how the world is, and you use that to explain your data. And the basic problem of probability, for example, is how do we explain the actually observed relative frequencies that we see in the real world? What are those relative frequencies coming from? And what is
let me use that? You're speaking with the language of models, and I think that's maybe a nice angle to bring out the point that I'm trying to make here about how Cubism would, I think, how it would think about models. Because as science definitely progresses in some way, right? Our models, they become more elaborate, more detailed, more precise. But what is that progression? Are we progressing towards a closer and closer approximation of the way that the world truly is? And my point is that Cubism would say, no, that's not the way to think about what's happening. It's more analogous to a Darwinian evolutionary process. When you see animals evolving in the jungle, each one's becoming more and more complex and refined, but you would never say that an animal is evolving towards some more true image of what a bird or an elephant is.
Yeah, but
it's an evolutionary process that's open-ended.
I don't see this evolution. The way that you simulate a many-body quantum system is based on a small set of laws, which have remained pretty much structurally unchanged for the past 80 years or so. With some developments due to quantum field theory.
I'm so sorry to interrupt, but I do want to make sure that there's adequate time for other questions.
Yeah, sorry.
Like, if you're willing to hang on to your question, and we could have a longer discussion during the.
That's it. I just wanted to make that point that I think the vast majority of philosophy didn't see an antagonism between epistemology and ontology.
I have a very quick follow-up question. I tend to prefer not to ask questions till everyone else has had a chance, but it directly follows from something that Mike brought up. This dichotomy or dualism between ontology and epistemology, where does nomology fit into this story? Like, I feel like there's a bit of a false choice between those two possibilities here. There seems to be something else beyond things that like physically exist and what we can know about nature, which is some law-like thing. And depending on one's view about the metaphysics of laws, one could take different points of view, but at the very least, I feel like there's arguably something else there. And I'm wondering if that's something you might comment on, because nomology seems to play a very important role in cubism.
Yeah, are you thinking of like Chris calling the Born rule a normative rule?
In a sense, right? There seem to be laws that say how the pieces of quantum mechanics are supposed to work that don't seem to be ontological necessarily, but also not epistemological. Anyway, I'll let.
Yeah,
a quick follow-up.
I would say I left that out partly deliberately because it's still very much open. I have my own thoughts about it, which tend towards saying that something like the Born rule, when we say it's a normative rule, it's objective in the sense that it's invariant across the set of agents that we're considering. You know, agents doing quantum theory and so on. They all use the Born rule, whatever particular states they might put into it, they use the same rule. But it's the connection between the shape of that rule and ontological reality is not at all clear to me. Certainly, I wouldn't literally say that the Born rule is like a structure that's out there in the world. It seems more to be something that describes this set of agents' interactions with the world. But I don't know how to articulate that. And
then why is it true? It must be a fact about the world that makes it true.
Yes, but the fact about the world that makes it true need not itself directly look just like an equation, if you like.
That fact being true is what makes the Born rule true, and is also what makes it true. The relative frequencies of experiments are predicted accurately. That's the interesting question.
We should move along. I want to make sure we have time for a break. We have time for now for just, unfortunately, one more question. It'll have to be quick. But again, I'm keeping track of everybody, and there'll be time for everyone to ask questions. Just please stick around for the final hour. I have a question from Saslav.
Hi, Jacques. I really enjoyed this very much. And actually, I had a different question, but last part now provoked me to reformulate this and focus on ion excess, which I really think it's somehow very important. And so you suggest that there's kind of a group of the observers or islands or bubbles, I would say, like a Wigner bubble and friend bubble, in which they can share measurement events and experiences. And I find this important in a step forward in the whole program of QBism, because I had a feeling that Chris quoted this kind of Jane's unscrambling the omelet, that QBists were not doing well in unscrambling that. We're doing until now exactly opposite, in a sense that when we talk about probability assignments of different observers, the fact that they have maybe different priors and different probability assignments is a true statement, but it's kind of trivial. It doesn't distinguish even classical situation or quantum, that maybe probabilities cannot be reduced on some ignorance about the facts of the world is a reaction of Bell's theorem. It's a natural reaction, and that's the path to go. But it doesn't tell you more about the structure. And now I feel for the first time, something very fundamentally is different than in classical physics. That might give some kind of a more detailed structure. And so you speculated about a new ontology coming of that. Do you think that this idea alone is sufficient to derive maybe the structure of quantum theory? What's your feeling?
Yeah, I mean, you know, I like to say that Cubism has at least 3 different projects. You know, there's the project of just treating it as a decision theory, which is fairly instrumental in its approach. But then there's also the ontological project, which is what I've kind of been aiming at here, which is much less developed. But then there's also the reconstruction project. So whether we can distinguish particular axioms or postulates from which we can reconstruct quantum theory. And these all kind of feed into each other. And I do think that by investigating these ontological ideas, we might gain greater clarity into how to succeed in the reconstruction program. You know, a problem is that there are so many reconstructions with different motivations that I feel like we need to have some kind of input from ontological principles in order to motivate what those reconstruction axioms are.
Thanks.
All right, so unfortunately, we're going to have to pause on the questions for now. Hang on to your questions. Again, I've recorded everybody. And everyone should take a few-minute break. We'll reconvene, I guess, at 2 minutes after the hour. And during that time, Chris can set up his slides. So take a few minutes, everybody. And I want to thank Jacques again for a wonderful talk. Sorry. Yes, excellent talk. And great questions, everybody.